Okay, so we're going to continue working through chapter 6. Luckily for you, we have this section and one more. Okay, so we are looking at taking a test a week from today. Okay, we'll do 6.4 today and tomorrow. 6.5 is a short little section we'll do on Monday. And then Tuesday, Wednesday, we'll review for our test on Thursday. Okay, so those quiz corrections, pretty important. If you missed more than you thought you should have, let's get those mistakes fixed so that come test time, we don't do those again. Okay, so chapter 6 has been all about exponents. Today, I want to talk about the difference between exponential growth and exponential decay. In section 3, we learned how to take a chart, something like this, and determine, is it linear or is it exponential? Okay, so like we can look at these charts and we can say, oh, I can see that this one is linear because we're adding the same number every time. And I can see that this one is exponential because we're multiplying by the same number every time. But notice how these y values get smaller and these y values get bigger. Okay, they're both exponential, but one's growing and one is what we say decaying. All right, so back to here. Okay, exponential growth. Okay, we say is an amount that increases by the same factor. Now, I know that you're still kind of new to some of this vocabulary, but when we say factor, that is another word for multiplication. What was that? Okay, so when we're talking about exponential growth, we are multiplying by the same number over and over and over to where our amount continues to increase. Okay, now we have the same definition here for decay, but what's going to be different? It's not increases, it's decreases. I really love that I can just copy paste. Too bad you can't.
To stay after a little bit.
Okay, now exponential, we are always multiplying by a number. I am going to go back to these right here. Okay, you just look at my board. Don't worry about you switching to a different page. So I want you to decide. I want you to just like, what do you notice? What do you wonder? One of them's exponential growth. One of them's exponential decay. We need a way to figure out how do we know which one is which. So just talk about it at your table. What do you think the difference is going to be when we look at, okay, yeah, we know increasing versus decreasing, but what's special about the number that we're multiplying by? Have a conversation.
Oh, hey, that's another thing.
Oh yeah.
All right, so I want to know what you're thinking. Green table back there. Anything that you're thinking right now? You just noticed that one was increasing and one was decreasing. Did you look at the numbers that they were being multiplied by? This is true. Not going to affect our final decision though. Okay. Red table, what'd you guys talk about? Oh, 1/2.
1.5.
Okay, so this one we're being multiplied by 1.5. Okay. What about the second one?
It's decreasing while increasing by sorry, it's decreasing by times 1.5.
Okay. So instead of saying dividing by 4, he said multiplied by 1/4, and I like that. So what is the difference between these two?
The way that it is, basically, they are, how do I say this, but technically they are just being subtracted.
Right, right, and that's how we know it's exponential.
And it's also not being multiplied by a whole number.
Okay, and we could have a whole number. A whole number is fine.
I know, but like,
Okay.
that's the way it is.
Yep, these two happen to be fractions. Rational numbers. What's true about this number versus this number? We can compare it to one number. Okay, so it's like 0.25, it's 1.5 or 3/2. Amelia. Ding, 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 ding. Okay, when we are multiplying by a number bigger than 1, we're going to grow. When we're multiplying by a number smaller than 1, we're going to decay.
Whoa.
Look at that. Okay, so we will go back to here. All right, and this is what's going to happen. Okay, we have an equation for exponential growth, and this is what happens. So we have our initial amount. Okay, A. We have a rate of growth. We're going to put it in decimal form. And we're going to say 1 plus R. That's our growth factor. So it's going to be a number bigger than 1. Okay. And then we raise it to the exponent of however long this is happening. Okay. We're typically going to see this in years. Okay. So we have this rate of growth. And since we're growing, like if our class was to grow by 5%, we have all of our class. We have 100% of our class, and then we're going to add 5% more. Okay. So we have the whole thing plus what we're adding. Okay. So that's why we have that that 1 added to the rate. Did you not have your, I imagine that. Ooh, 5%, 2, 4, 6, 8, 10. Would it be an exact? It'd be about 5.
But
So we just have a limit.
Yes, yes, that's what would happen. Okay, so here's the example that we're gonna do. Are you ready? La Vista Middle School we're gonna approximate 750 students. If our population, and I'm talking about student population, increases by 2% each year, How many will we have in 5 years? Okay, so let's write that down. Write down the important information. We have 750 students. Our population is going to grow by 2% each year. How many will we have in 5 years? So first of all, I want you to have it written down, so I'll wait. Okay, so using this formula, what do we start with? How many do we start with? Okay, so A is 750. Our rate of growth is 2%. So our rate, we don't say 2. 2% means 0.02, buddy. Too many zeros there. Okay. 0.02 would be our rate, and our time would be 5 years. So when we set this up, we have 750 times 1.0.02 raised to the 5th power. The one's always going to be 1.
I was wondering what that was.
Okay. So we have 750 times 1.02 to the 5th power. Cool. So if I take 1.02 to the 5th power and I multiply it by 750, we would have 828.0606, blah, 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 blah. Okay. Elliot, can we have 0.06 of a person?
No.
No, 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 let's not. Oh, let's talk about order of operations. We have to take care of our X. I'll wait for you. Order of operations. We have to take care of our exponent first. So 1.02 to the 5th power. Then we can multiply that number by 750. Okay. Yes.
Is there also parentheses first?
So inside that's why we did this first. Okay, parentheses, then exponents, then we can do all that. Okay. Okay, now, guess what? We have the same kind of thing, turn the page, for exponential decay, but notice we have initial amount is still A, our rate is still R, we still have time, but notice since we are decaying, we're taking 1 minus R. So that number is going to be smaller than 1, which is what is giving us our decrease. Okay. What is something that decreases in value the longer you have it?
Money.
Car.
Your car. Okay. You drive that car off the lot and it's already going down in price. Okay. So, for example, let's say you buy a car for $21,500. Okay.
That's a pretty expensive car.
Actually, not really. That's a pretty cheap.
Buy.
Right, right. But if you go to buy like a new car, so this is probably a used car, okay, in today's world. Okay, it loses 12% of its value each year. How much will it be in 10 years?
It's not garbage by
Well, okay. Okay. So 21,500. What is that?
Hey.
Thank you. That is our initial amount A. Okay. 12% is our rate, but are we using 12?
No. 0.1.
Okay. What does what mean? It's a percent. And then T is 10. Wait, what? Okay, so you're working ahead of me here. Hold on. Say timeout break. Okay, so y equals a times 1 minus r raised to the t. Okay, so we have 21,500 times the quantity 1 minus our rate of 0.12 raised, hold on, raised to the 10th. Now, this is what you're thinking, Elliot. We need to take 1 minus 0.12. Well, that would be 0.88. Okay.
Negative.
Not negative. 1 minus 0.12. Okay. So now if we take 0.88 to the 10th power and leaving that in our calculator, so take 0.88 to the 10th power, leaving that in our calculator, multiply it by 12,500. We're talking about money. We have 3,481.26. Is that what you get? My calculators out there? 88.88 to the 10th power. And then take that number and multiply it by 21,500. Okay, so I want you to turn to page 187 and I want you to look at 6 through 8. And I want you and your elbow partner to decide if these are exponential growth or decay. Ready, set, go. 6 through 8, growing or decaying?
That's growing.
But we're multiplying by what number every time? The number in the parentheses I want you to look at. Remember, one's bigger than one, one's smaller than one. Okay, so like in number 6, this 0.95, is it bigger or smaller than 1? So then is it growth or decay? Okay. So 0.88.
Because you have to like add it or subtract
Times 21,500.
I need 20.
I don't know. What did Miss Woman do?
Do just point.
Miss Homan made a mistake on our last example. I don't know what happened. Well, that's why you speak up. I said, do you agree? And everyone's like, there is like 10 people with calculators. So fix that. All right, here we go. So let's talk about number 6, 7, and 8. All right, pay an F. Growth or decay for number 6? How do you know? Okay, our number that has the exponent, that's the number we're multiplying by every time. It's less than 1. Okay? Kane, how much less than 1 is it? All right. So our rate would be 5%, that 0.05. Okay. Amy, what about number 7, growth or decay? And how did you know that? Okay, our number that we're multiplying by every time is greater than 1. Specifically, Holden, how much greater than 1 is it?
Oh, 8%.
Ah, he even went a step further. 0.08 is how much more it's greater than 1. So 8% is our rate. Okay. Last one. Number 8. Elliot, what do you think about number 8, growth or decay? Okay. We have a number that is less than 1. All right. Colin, how much less than 1 is it?
25.
Okay. So our rate of decay is 25%. You have a question? You do not have a question. Okay. Okay, so this is what we're gonna do. Your homework